So first of all, can everybody hear me? Fine? Alright, that's great. So before we start with the actual presentation, I would like you all to imagine watching a video online. And chances are quite high that you're now imagining watching a video on some sort of a streaming platform, like, for example, YouTube. Is there anyone who's actually thinking about the joys we had in the late 1990s by clicking a download link, watching half an hour to download the video, open it locally on our Windows media player? Was there anyone of you who was imagining that kind of scenario? No one, okay. So, the watching of videos as a streaming service is very deeply embedded into our digital lives. But when it comes to reading documents, we tend to be rather old-fashioned. And it's the same thing in DSpace. For example, if we take a look at this nice document, it's a high-detailed scan by an 1875 document from the Saussure. And we see that it's 670 megabytes in size. Now, if I would like to start reading this document in a default DSpace, we would first need to download the entire document, open it locally, and then we're just able to read it. Now, if there is a way to instantly start viewing the videos, isn't there a way to do the same thing for documents? And the reason why we are able to instantly view videos is simply because we're streaming them. And streaming means that instead of downloading the entire audiovisual file at once, we're going to split that file up into several units. The first units will be downloaded first, and while we're watching those, the subsequent ones are being downloaded. We can do the same thing for documents, but of course, we first need a unit for our documents. It's not too hard to find a unit in a document. You can simply pick pages, of course. So we'll take pages as our streaming unit. Now we do have that unit, but we still need a way to present it. And if you go back and take a look at this document, you see that it contains a rather old-looking font, and it also contains an image. And those are things that are difficult for a browser to present. So we need a way, an easy way for a browser to present, because most browsers only support the limited set of fonts. And those aren't shared across all browsers. So we need a way to, first of all, make it easy for all browsers on all platforms to present this document, or to present our streaming unit, being the page. And in the meanwhile, we do want to keep our document in its original integrity. We don't want to lose any of the fonts, we don't want to lose the images. And there's one way to do this, to make sure that really everything is preserved perfectly, and that's by making an image of each file, an image of each page. Now, we are aware that for some particular document types, for example, digitally created documents, for which the layout isn't important at all, there are some more efficient ways of presenting this, but our goal was to make sure that we were capable of presenting a document in its original integrity and for all document types. So this is something that we can still do as an improvement for future versions, that we would go and pick the method of presenting based on our document type. Now, if we would only make one just very large resolution image out of every page, and imagine that we're going to start reading our document on a mobile phone, chances are rather high that our image is, first of all, too big in dimension, so it will have to be rescaled, made smaller to fit on a mobile device, which, first of all, creates a loss in quality. And secondly, an image with a large dimension also means that it's a sizable image, which takes up a lot of disk space and which takes more time to download. So instead of creating just one image out of every page, we're going to make a range of images, going from a very high resolution, large image, over to a small one. And by doing so, we allow this technology to go and pick the right size, the right dimensions of the document, based on the viewport dimensions that we're going to present it in. So for example, if we take a look at this document, it's another document by, I think, by Mr. Antelman. If we're going to read this document on a desktop computer, we'll get to full scale, the full detailed image. When we take a look at it on a mobile phone, we get a slightly smaller image, which is more quickly to download and which gives a high detailed image on our mobile phone. But of course, let's say if we still want to zoom in on a document and we do need more detail, we do need a higher resolution image, then the document stream can simply load one of those more high resolution images and present it within our device. Now, how does this streaming process work, or what happens when we start viewing or reading such a document? So when our user opens a document in the viewer will first of all go and fetch an index of all of the images from all pages. It's just an index. And at the same time, it will also load all of the thumbnails for each page. These thumbnails will be presented in the sidebar just for navigating purposes, and they will also be working as the placeholders for pages that aren't loaded yet. But of course, we do want to start reading our document instantly, so the viewer will also address the REST API and fetch the image that the page that we're currently looking at, and of course in the right dimension so that it fits perfectly to our viewport dimensions. Something that looks rather logical, rather evident, is that we as a user, we do expect that we can instantly start searching through a document. But when we're streaming our document, that becomes a bit challenging, because we are not sending all of the images that make up our entire document to the end user. We're just sending what they need and what they request in that moment. So we need a way to stream our search as well. And we're doing this by what we tend to call a layered search system. And that works in the following way. When an end user enters a query, our viewer will send that query over to the REST API and over to our actual search engine. And that search engine will go and start looking in a general search index. And that general search index contains all of the words in the document, together with indications of which page they occur on. It sends that information back to the viewer, which will then jump automatically to the first page on which that search keyword occurs on. And in that moment, our viewer will go back, will address back to the REST API and retrieve a text layer for that current page that we're looking on. And that text layer does not just contain all of the words, or all the keywords that occur on our page, but it also contains their spatial coordinates. So that allows our viewer to go and highlight all of the keywords on that page. So without actually downloading all of the images and all of the high detailed search indexes, we are capable of instantly searching our entire document, regardless of its size. Now, from a more technical perspective, how do we prepare our documents for streaming? So first of all, we start with our original input document. So that one is submitted to DSpace, and it will be processed by Identify, which is part of the Image Magic suite. And Identify will start and collect will collect information from our document. So for example, the amount of pages, their aspect ratios, and after that, each and every page will be processed separately. On that page, either XPDF or GhostScript will create a very high resolution image of it, which will not be used for streaming, by the way. That high resolution image, high detailed image, will be merely functioning as a reference image on which all the scaled images will be created. So image scale will then go and scale all of those pages into the aspect ratios which were predefined by Identify. And then we get, of course, a lot of different, a lot of images with different dimensions, but which are still, well, rather big in file size. So the next step will logically be to reduce the actual file size, so to make sure that it's more quickly downloadable. And we first do it with a lossless compression method. So with this lossless compression method, our file size will be reduced, but we still get the same image quality. So we do not lose any quality. And that's done by default. And after the lossless compression method, there still is the option to go even a bit farther and to use a lossy conversion method, which will then further reduce the image size, so that the actual disk space it uses and the actual bandwidth that will need to be downloaded. Now, although this lossy compression method does not reduce the quality on a very noticeable way. So whether or not, for most types of documents anyway, so whether or not a certain repository will benefit from that extra lossy compression method depends on the type of documents which are in the repository. This entire conversion process, after this conversion process, we will end up with an amount of scaled and compressed PNG images, which are then logically created into bit streams and stored in an image bundle. But of course, in the same, or during this process, we also need to prepare our document for search. And that's done by creating a JSON file from the entire document, which contains the entire text layer of our document, and then go and split that JSON file up into several smaller JSON files, each one for every page, of course. And from those files, we can actually create our search indexes. Once again, after that conversion process, we end up with several JSON files, which are then stored in a metadata bundle. Now, as we're living in the mobile era, people tend to use their mobile devices more and more to visit websites. And of course, they're also using those devices to visit repositories. So to make sure that this would actually meet modern day requirements, we had to make sure it was optimized for mobile use. So first of all, we gave it a responsive design, of course, which means that when we take the interface, the user interface of the document streaming, will ultimately reshape itself based on the viewport dimensions, so that all the functionality keeps conveniently, keeps easy to use. But of course, we're supporting all of those common gestures that you're used to use on your mobile devices. Now, if it's that obvious that you benefit from streaming documents versus downloading them, or having to wait to download them before you can actually start reading them, you can easily ask yourself, well, if it's that obvious, why doesn't it exist? And the thing is, there are services like this that already exist, but those require you to rely on their external services, use their streaming services, and rely on whatever service that they will provide you with. This is two main consequences. So first of all, you lose the control over your access restrictions. Let's say that you are using such a third-party service like issue or script, and you would change your access policy, or you would, for example, make a publicly available item access restricted, then it's still publicly available by that viewer. So you lose your entire control over your access. In the meantime, you also do not have any control over your content availability, because you will have to rely on a third-party streaming service on there and use their streaming service. So if they change their policy, discontinue part of their service, or do whatever they want, then it might have some implications on the availability of your content. So that's something that we made sure that this module is actually capable of running entirely on your own infrastructure. So it doesn't need an external party streaming server or service or whatever. The only thing that you need is your own infrastructure, and you are the streaming service in this way. So if we don't need an additional streaming service, we don't need a third party, well, why do we need DSpace? So we did make a version which actually doesn't need DSpace, which, for example, can be run out of a Node.js server and can be easily integrated in another application or another website or platform. And the reason why we are able to do this is actually very simple, because we built our viewer, our client, on top of an extension we made to the DSpace REST API. So if you can serve the same REST endpoints to the viewer, that's the only thing that you need to integrate it into another platform or application. And in terms of conversion process, this is actually really the same as what would happen in DSpace. It uses the same steps, but of course there are some small differences. For example, if we would take the example of our Node.js server, of course we can't use image scaler as our Java library to rescale our images, because we're on a Node server. So we'll need a Node equivalent for that. And the entire conversion process will also not just be coordinated by a Java media filter, but instead we'll need to use a Node script. But apart from that, it is similar to the way it's been done in DSpace. So, in conclusion, we made sure that we're streaming documents by streaming the images of each page to the end user so that they can instantly start reading a document. We're using a layered search system because search becomes a bit more challenging when we're streaming a document and not sending it at once. We also made sure that it's optimized for mobile use, because of course we are living in a mobile era and we'll be using mobile devices more and more. And we don't need any additional service, or even if we want to, we don't even need DSpace for it. Now, I think, let's see if the Wi-Fi does work over here. I'm going to switch over to a page in DSpace. So this is just an instance, a quick instance that we set up to demonstrate this. It's an empty DSpace apart from this. And let's say that we're going to download this file. This is once again the file by the Saussure, so it's 670 megabytes inside. So yeah, let's start downloading it. I'm quite keen to see it, so I'll be back in 20 minutes. And then or we can just use the viewer, well, why not, if we have it. So let me cancel this. Go on the viewer, and let's go immediately to a page. Let's say that we're going to watch page 20. You see that I'm already too late. So you see that after we see a fake image, which is actually the placeholder image, this high resolution because we're on the desktop. This high resolution image is instantly and to demonstrate that the search works as well, so let's search for the. All right, we have 2,782 search results, which are immediately highlighted. So, well, this is part of our commercial line, just as a side note. So if you have any specific questions regarding your DSpace or interest, just grab my shoulder after this presentation. But I think we still have some time left. So, all right. So if anyone has some questions regarding the technology we used, or
yes, so any questions that you want to start?
Is it possible to select text? Copy paste?
This implication is not yet possible. No, so that's something that we're still working on currently.
Is there some link where we can either see it in action or download some code base?
I'm sorry, I did not quite understand.
Is there some link or some address where we can either see it for ourselves in action or actually download the code base?
I
So,
just tweeted the link right now, so if you do twitter.com/@Meyer, there's a live link and you can open it right now.
Okay.
Hi. To give the expression starting from the PDF, we could actually start from TIFF in our DSpace. I suppose we could get this work like that as well.
yeah, so at this point we choose to only use PDF, and there's a particular reason for that. Because if we would support multiple files, well, one of our main goals and main requirements was we were able to reproduce or to keep all the documents in its original integrity. And well, during the research for this project, we thought that it's better just to start with PDF because it's the only way that we're actually sure that we can guarantee that the document will be in its original integrity. But I think Art has something to say about that.
Yeah, we can make it work with TIFF with only a small customization.
So it is possible, yeah.
Will we have to?
Other questions? Yes, I have one for you. So, I'm sure you probably heard of IIIF.
Yes.
I'm curious, what do you see as the parallels between what you're doing here and what we could do with IIIF, or is there an opportunity here to
So the reason why we built this in this way and not with IIIF because it was when the developments and the research for this project started. IIIF wasn't at the stage that it is right now. So Art already mentioned to me that there is some potential for IIIF, but our main thing is that we're not simply our goal isn't to present images as such. We want to present the document. So maybe a more logical step as the next development step would be to go and see if we can use several ways of presenting, not just by images, but using more efficient ways depending on document type.
Other questions or comments? End a little bit early then, I guess. I want you all to join me in thanking Ignace